Welcome to Methamphetamine. Today we're gonna do this integral. Super crazy integral. You see, we have definite integral mixed with determinant, and then we have limit, and this is absolute value. This is absolute value here, and this is determinant. So, how can we pronounce this? I don't know. The integral of x power of the integral of sine of ln x over 1 plus x squared going from 0 to infinity times tangent power of limit x approaching to the integral of ln x from 0 to 1 x squared minus 1 over x minus 1 raised to negative 1 power going from the determinant of this and this. And how we do this? So we're gonna finish them one by one. So, which one do you think is easier? I'm going to do a determinant first. Let me just figure out what's the lower limit and upper limit. Let me just do a lower limit here. So here is the deal. You see, this is the determinant of this sine x 0 cos x 0 1 cosecant x. And cosecant x, let me write as 1 over sine x. Because let me just do it here. Sine x 0 0 negative cosine x 1 1 cosine x. Let me just write as 1 over sine x, because it will help us to do it easier. Just first, to do the determinant, let me use the quick way. This time this, it becomes sine square x, and then here this time this over you get 0, and then this time this over you also get 0, right? And the second row, just cos x times 1 time negative cos x, you get negative cosine square x, but we're gonna add a negative here, so negative they become positive, so this is just positive cosine square x. And then this time this is just minus 0. And then here, this time sine x times 1 over sine x times 1 over you get 1, but we're gonna subtract by 1 here. So over, look at this, sine square x plus cosine square x. This is a famous identity which is equal to 1, and then we're gonna minus 1. So over this is just equal to 0. The determinant of this is just equal to 0. So let me just erase this. We can erase this now, and then also erase this. Yes, this is the determinant, and this is just 0. The lower limit is 0, right? So next we're gonna figure out what's our upper limit. Upper limit is way harder. So first we're gonna do the integral. What's the number here? We're gonna figure it out. So we're gonna do integral of 1 over x times ln x squared dx going from e to infinity, like that. So here's the deal. I would like to use let u is due to ln x. If then du is just due to 1 over x dx. So over 1 over x dx is just our du. So, but we're gonna figure out what's our lower limit and upper limit. Plug e into the ln, you get ln e is just 1. Put infinity inside it, you get ln infinity is just infinity. So because 1 over x dx, they become du. So over you get 1 over, and then our ln x is just equal to u, so square that you get u square and then du. So over you will get the integrate 1 over u square, you get negative 1 over u, and then going from u out of a from 1 to even, like that. So over plug infinity, negative 1 over infinity, over you get 0, and then you gotta subtract 1 over 1 is just 1. Subtract negative 1, you get 1 here. So here, this one is just equal to 1. So over you get like this. 1 minus x squared dx, like that. So we're gonna do another integral here, the definite integral. The integral of square root of 1 minus x squared going from -1 to 1. We can do this by using the geometric way. So let me just put down the integral here. If we use the u-sub, it will take a lot of time, so don't do that. So whenever you see square root of something, some numbers minus x squared, so over, let me just draw the graph. Just take a square root of this, square root of 1. So over is just 1 square, so square root of that, you still get 1. So you cannot get a semicircle like that. This is the x-axis and this is the y-axis, and you get a semicircle, and then this -1 and 1. However, the original question, and this is just the graph of this 1 minus x squared, square root of 1 minus x squared. However, you see, luckily you see the integral is going from -1 to 1. It's just the area of this function, right? So for the area of this semicircle, the area of a circle is pi r squared, right? So far you get pi times our radius of the semicircle is 1 squared. However, this is a semicircle, right? The area of a circle is pi r squared. Whereas if this is a semicircle, you're gonna divide by 2 like that. So far you get pi over 2 like that. So overall, our upper limit is just equal to pi over 2. Our upper limit is pi over 2. So overall, next thing we're gonna figure out what is this. The integral of sine of ln x over 1 plus x squared, going from 0 to infinity. It seems like it's really difficult here. So let me just do this. And do we need to use our Feynman technique here? Not Feynman technique, I mispronounced this once again. Sorry guys. So do we need to use the Feynman technique here? No, because as I said, just it wastes a lot of time, right? So I'm not going to waste a lot of time in this integral. I think we can also solve this by using the Feynman technique. Put an a inside, right? But let me just use another trick. So here's the deal. Here's a really special one. So over, we're gonna let our x is equal to 1 over t here. You will see why. And then our dx is just equal to -1 over t squared dt. So over, we're gonna figure out what's our lower limit and upper limit. We're gonna get back to our t row. So over, t is just equal to 1 over x. However, you can just put it inside because the order just switches. So over, you just need to put 0 like that. So over, it doesn't really matter if you just put 0 inside. Just this kind of lazy, right? So over, put 0 inside, you get 1 over 0 is infinity. Then 1 over infinity is just 0. And then the outside is just negative. And then -1 over t squared dt, right? And then on the top you get sine of ln of 1 over t over 1 plus 1 over t squared, and then multiply by 1 over t squared like that. Because we put the negative sign outside. And here, thanks to this negative, we can just switch the order of the lower limit, upper limit. You will get the integral going from 0 to infinity. And then here, multiply inside, you get t squared, and then t squared and t squared that cancel it, you get t squared plus 1. But let me just follow the order of this. The order of this. 1 plus t squared dt. So over this, do this in our head. Sine of ln of 1 over t. ln of 1 over t, you can write this as ln of t power of -1. And then the -1, you can put it outside the integral, outside the ln, right? So over you get sine of negative ln(t). And the sine of negative something, because sine is an R function, you can just put the negative sign outside. So over you get this negative sign is just let me show some steps to you guys. ln of negative ln(t). So because sine is an even function, R function, you can just put the negative sign outside the integral. Because sine of ln(t) over 1 plus t squared. So here, since t is a dummy variable, you can name it whatever you want. You can name many variables, but let me as x, sine of ln x over 1 plus x squared dx. So overall, we let I equal to this, the original integral. We know that the original integral is due to the negative of this. So if you add them up, you get 2i, right? It's just equal to this plus that. They pretty much just cancel each other, so you get 0. So overall, your I is just equal to 0. So overall, the answers to this integral is just equal to 0. How cool is this though? So this is just equal to 0, the integral of this. So over you get x power of 0, right? So x power of 0 is just 1. So 1 multiplied by that, so just that cancel out. So over we pretty much just get that. So over we're gonna do this. So let me just figure out what's the number here. Limit at x approaching to something. So let me just do this first. The integral of ln x dx going from 0 to 1. This is a really famous one. You know, when you need to integrate ln x, you need to use the integration by part. Put the d and I here. We're gonna differentiate ln x, and then we're gonna integrate 1. Differentiate ln x, you will get 1 over x. Integrate 1, you will get x. So for this time, this is the first part of the answers, and then you follow everything from 0 to 1. And then x and x, they are cancelled, and then the product is just the integral. So this 1 dx, 1 from 0 to 1. So for if you plug 1 inside, you pretty much just get ln 1 times 1, right? You just get 0. However, whenever you put 0, you get 0 multiplied by ln 0. And ln 0, it should be 0 plus times ln 0 plus, because if this is 0, just 0, you get indeterminate form. So, but this is still indeterminate form, because ln 0 is just undefined. But ln 0 plus is approaching to negative infinity. However, here we're gonna do more work. Let me just use a limit at x approaching to 0 plus. And then, because this is an indeterminate form, so we're gonna use our last Waiter rule. Make sure you will have a function in the numerator, so we can use our last Waiter rule. Last Waiter rule, just we need to put ln x here, because when you differentiate it, you just get rid of the ln, right? So ln x over 1 over x, so you can use our last Waiter rule. So over you get limit as x approaches to 0 plus 1 over x. Differentiate ln x, you get 1 over x. And the differentiate 1 over x, you get negative 1 over x squared. So we do this because we're gonna use our last Waiter rule. As I mentioned before, 0 times negative infinity. So 0 times infinity, like that. Never mind if you don't put down negative. 0 times infinity. So for divided by negative 1, let me just put down the, because divided by negative 1 is the same as multiplied by negative 1. So I'm going to put the negative sign outside the integral. and then multiply by x squared on both sides. So over this x squared and this x squared, let me show you. This x squared and this x squared, they cancel each other, and then x squared over x, you get x. So far, if you plus 0 into it, so far you get 0. So far you're gonna subtract 0 here. So the integral, the limit is up, going from 0, so going to 0, goes to 0, like that. So over integral 1, you get x. You are fading from 0 to 1. So you get negative of 1 minus 0, right? So over you get negative 1. So over the answers to this integral is just equal to negative 1. And then we're going to take absolute value of negative 1, right? So over you will get 1 here. Absolute value of this answers. So you get limit, right? Limit at x approaching to 1, right? And then we're gonna do a limit at this first, and then we're gonna raise to negative 1. It's the same as 1 divided by it at this point. And this is not a matrix, be sure. So we're gonna do a limit as x approaching to approaches to 1, and the x squared minus 1 over x minus 1. So if you plus 0, you get 1 minus 1 is just 0. 0 over 0. I think you can use the last Waiter rule here, but using last Waiter rule all the time is too boring, right? So let me just here, don't just put 1 inside. We're gonna factor the x squared minus 1. Factor it, you get x minus 1 times x plus 1 like that, divided by x minus 1. So over x minus 1 and x minus 1, they are cancelled, and then put 1 back to it, you get 2, right? So over you get 2, right? And then 2 power of negative 1 is what? It's just equal to 1/2. So over you pretty much just get tangent x power of 1/2 like that. So tangent x power of 1/2 is what? Square root of tangent x. Let me write it as square root of tangent x. So overall, let me just write down the original integral to you guys. We're gonna integrate. We're gonna integrate square root of tangent x dx from going from 0 to power over 2 like that. So to do this integral, first step we're gonna do something. We're gonna let our I is equal to that. And then we're gonna use our formula, and this is a really common formula. Whenever you're gonna do the integral going from 0 to a like that, and a is greater than 0, and then the integral of f of x dx going from 0 to a, and and this is just the integral, the same as the integral of f of a minus x dx going from 0 to a. Be sure x should be greater than 0 in this form. So I think equal to 0 is okay, but why do you put a 0 here? Just really boring. Just 0 is equal to 0, and this very normal, right? So overall, we're gonna use this formula. You get square root of tangent, and then x we're gonna put pi over 2 minus x like that. And then what is this? Tangent of pi over 2 minus x, and this is a very famous identity, and this is just equal to cotangent x dx like that. So I'm going to erase this like that. So okay, because the integrals of this is equal to that, right? Definite integral. So we can add them up because they are equal. So 2I is equal to the integral of square root of tangent x plus square root of cotangent x dx, like that. So overall we're gonna integrate. However, you see, square root of tangent x and square root of cotangent x is really hard to integrate, right? But this an definite integral. So overall, I'm going to write this square root of tangent x as psi x over cos x, like that. Square root of that, and then plus cotangent x is just cosine x over psi x, right? And then take a square root dx, like that. So overall, we can get our same denominator. So you pretty much just get square root of cos x and the square root of psi x here, and then multiply each other to get the same denominator. Square root of cos x multiplied by square root of psi x. So let me just write down as square root of psi x first, and then multiply by cos x dx. So overall, square root of psi x to get the same denominator, square root of psi x, and this square root of psi x need to multiply by square root of psi x, right? So overall, you get psi x here. And then this one, square root of cos x, you're gonna multiply by cosine x. So square root of cos x multiplied by square root of cos x, you get positive cos x. So okay, here's the deal. I would like to get something here, and then we're gonna use our use sub. The top psi x plus cos x, it should be parentheses psi x plus cos x multiplied by dx, and this is our du. We want something like that. So overall, I want something like psi x minus cos x here. So because psi x minus cos x, whenever you differentiate, you get cosine x, right? Differentiate psi x, you get positive cos x, and then differentiate cos x, you get negative psi x. But in front we have a negative psi, so over you get positive psi x. So for cos x plus psi x is just equal to psi x plus cos x. So we want something like psi x minus cos x here. So what should we do here? Let me try to square it. Psi x minus cos x. We're gonna square it. Let me see what we can get here. Because when you square it, you get 2 psi x cos x in the middle, right? Because this is the formula of a minus b and then square it. First you get psi square x and then minus 2 psi x cos x, and then you're gonna plus cosine square x, like that. So overall, psi square x plus cosine square x is just equal to 1, and then you're gonna minus 2 psi x cos x. I'm not going to change 2 psi x cos x as psi 2x, because what can we do about the 2 psi x cos x? We can get something like psi x minus cos x inside, right? So overall, let me just move negative 2 psi x cos x on the left. You get let me erase the derivative like that. So you get 2 psi x cos x is equal to 1, and then move this to left hand side, right hand side. This parentheses psi x minus cos x and the square. You get negative parentheses psi x minus cos x square, like that. So here's the deal. We can get something like psi x minus cos x here. So we're gonna use our u sub x, right? We can use our u sub. So we know 2 psi x cos x is equal to 1 minus that, but we don't have a 2 inside. So let me just multiply by square root of 2. Like square root of 2 multiplied by that. But don't forget to multiply by another square root of 2. So make sure you get the original question. So you pretty much just, since I don't have enough space, so let me just write it here. Square root of 2 multiplied by the integral of that. sine x plus cos x over combine square root, you will get square root of 2 sine x cos x. So 2 sine x cos x is just equal to that, right? 1 minus sine x minus cos x squared that. So here we can use up here because we know the derivative of this is just equal to that. So use up. Let u is equal to use up, not use up. Use up. So let u is equal to sine x minus cos x, and then du is just equal to cosine x plus sine x multiplied by this. Be sure you need to put a parenthesis, and then the top is just equal to du, right? So overall plus 0 into it. Be sure you need to change the lower limit and upper limit. Plus 0 into it. Sine 0 is 0. And then cosine 0 is 1. In front we have a negative, so over you get negative 1. Put power over 2 into it. Sine power over 2 is equal to 1. And then cosine power over 2 is 0. So over you get 1. And this is just, on the top you get 1. Multiplied by du. It's the same as du divided by that. So denominator you get square root of 1 minus this, just our u square. So okay, and since 1 over square root of 1 minus u square is an even function, so you can just double the result. So you get 2 times square root of 2, and then the integral of 1 over square root of 1 minus u square going from 0 to 1 du. Like that. So you can check it by let f is equal to f of u is equal to this function, and then put negative u inside. If you get the original, get the f of u back, and this an even function, you just prove it. And if this an even function going from negative a to a, you pretty much just double the result like that. And then 2 times square root of 2, give it. And then the integral of 1 over square root of 1 minus u square, you should memorize is, and this is equal to inverse sine of u going from 0 to 1. You're gonna evaluating from 0 to 1, and then 2 times square root of 2. First, you get inverse sine of 1, you get pi over 2, right? And then you're gonna inverse sine of 0 is just 0, so over you just need to subtract by 0. So final, we're gonna, you see 2 and 2, they cancel each other out. So over the integral of square root of tangent x going from 0 to pi over 2 is just equal to square root of 2 times pi, like that. And this is really, really cool. Be sure your pi shouldn't put it inside the square root. Be sure. So overall, this is just our answers. And this is really, really cool.